We are now in lesson number 6, Population and Sample.
This lesson is about the primary sources of data. The sources would directly provide quantifiable information, which the researcher will collect and process in order to address the research questions. This lesson on sample and population contains 4 simple steps. You will learn about study population, sample, sample size, and sampling techniques. The diagram indicates the sequential flow of research activities. Earlier, we have seen these steps when we were talking about the research procedures. In this context, the activities related to the selection of a sample of the study and data collection are in the 4th step. First, let's see what terms sample and population means. The main function of the sample is to allow the researchers to conduct the study to individuals from the population so that the results of their study can be used to derive conclusions that will apply to the entire population. It is much like a give-and-take process. The population gives the sample, and then it takes conclusions from the results obtained from the sample. A sample comprises representatives of a population that the researcher is interested in examining. It is a subset of a population, and it should reflect the salient and important characteristics of the population. Suppose a researcher is interested in studying the intention to adopt virtual banking among postgraduate students. The population of interest comprises postgraduate students, which could mean all postgraduate students of this university, or in this city, or the entire nation. Thus, the researcher should be prepared to clearly determine and define what she or she means by the study population. Once the study population is defined, the researcher should select a group of postgraduate students from the defined population. The selection involves making at least 2 major decisions. First, on how many students are needed, that is the sample size. And second, how to select them, which is the sampling technique. A study population or a research population is also known as a well-defined collection of individuals or objects known to have a common, binding characteristic, or trait. In our example, the common trait is postgraduate students. It can also be school children, government officials, retirees, or divorcees. The expression well-defined population refers to the extent to which the researcher manages the population. The researcher may loosely include in the study population all postgraduate students of this university, and even all postgraduate students of the country. On the other hand, he or she may only include the currently enrolled postgraduate of the university, in which the list of enrollment with contact numbers is readily accessible. Still, another researcher may opt for postgraduate students who volunteer to participate in the study. A well-defined population is helpful in that it provides informative and rich data about the characteristics of the study, which includes the total number of people in the population. This would lead up to the quality of the results of the study, particularly in terms of the generalizability of the results from the sample to the population. Therefore, be mindful that it is good practice to identify and define our study population to point that it provides a sampling frame, from which a representative sample could be extracted. So, is it important to get a representative sample? Sampling is the process of selecting a number of individuals for the study. Sampling is useful because 1. A good sample produces results that can be generalized to the study population. 2. It is cost and time effective. 3. It is manageable when the population size is too big. 4. There is a plethora of inferential analysis that allows the use of a sample in the estimation of the parameter, the true values in the population. A great sampling technique should enable the selection of in such a way that the sample truly represents the characteristics of the population. Now we are going to see how to get a representative sample. The process is called a sampling procedure. The figure illustrates the sampling process. Consider that you have already defined your study population consists of postgraduate students currently enrolled at your department. And, suppose you already have a sampling frame in which all of them are listed. The big circle contains the study population. Let's say there are 1,000 postgraduate students in your department. Assume that there are 750 male and 250 female students in the population. Using a sampling technique, which will be explained in a while, you may identify and select, probably 100 students, from whom you are going to collect the necessary data. This is represented by the smaller circle in the diagram. The sample is somewhat representative of the study population if you have selected about 75 males and 25 females. Of course, there are several other characteristics of importance that you have to include in your representative sample. In this situation, it is very likely that you will get results that could be replicated if you decide to examine the entire population. In other words, to get a representative sample, which is a bias-free and error-controlled, a researcher should 1. Define the population, make sure it is accompanied by a sampling frame. 2. Determine sample size. 3. Apply a probability sampling technique. What about the sample size? How many respondents are enough? The rule of thumb suggests that 1. The larger the population size, the smaller the percentage of the population required to obtain a representative sample. 2. For a small population, when the population size is less than 100, sampling is not useful. You may instead study the whole population. Here are examples of sampling techniques. There are many sampling techniques in quantitative research. The techniques are normally classified into two groups, probability sampling, and non-probability sampling. The use of a probability sample allows the study to take conclusions from the results obtained from the sample to the population. The probability sampling is also termed as random sampling. Accordingly, the figure indicates non-probability sampling as non-random sampling. As shown in the diagram, there are at least 4 types of random sampling. Each has its unique strengths and shortcomings. A researcher should make an informed and defensible decision in using a particular sampling technique. To conclude, please jot down 2 or 3 new ideas that you have gained from this lesson.